Somewhere in the middle of the Pacific Ocean, there's a mountain so big that if you tried to walk around its base without question, the single largest active volcano on the face of the Earth. And right now, deep beneath its summit, something is stirring. Magma is rising. The ground is swelling. Thousands of tiny earthquakes are rattling through solid rock every single month. And scientists who have spent their entire careers watching this giant are telling us the same thing they told us right before it exploded back in 2022. This is what it looks like before the mountain wakes up. This is Mauna Loa, and if you have never heard its name before, you are about to understand why it should terrify you just as much as it fascinates you. Let's start with the scale of this thing, because numbers alone will break your brain. Mauna Loa covers roughly half of the entire island of Hawaii. Half. Like one single volcano, so massive it swallows an entire island whole. From its base on the ocean floor to its summit, it stretches nearly 6 miles high, taller than Mount Everest when you measure it the right way, from root to peak instead of from sea level. It is built from an estimated 18,000 cubic miles of solid rock. So much material that if you spread it out, it would bury the state of California under a layer more than a mile thick. This is not a mountain. This is a geological event that never stopped happening. And here is the part that should really sit with you. Mauna Loa is not dormant. It is not extinct. It is not some ancient relic we study out of curiosity, the way we study a fossil. It is alive, active, and it has erupted 34 times since humans first started keeping careful records back in 1843. That is an eruption roughly every 5 years on average. It does not politely bubble like a backyard science fair volcano. It unleashes rivers of lava that can move faster than a car on the freeway, racing down its flanks toward the towns and cities that sit in its shadow. The most recent eruption happened in November 2022, and if you were anywhere near Hawaii that month, you remember it. After nearly 40 years of silence, the longest quiet stretch in the volcano's recorded history, Mauna Loa cracked open. Fountains of lava shot into the night sky, glowing red against the darkness, visible from space. Rivers of molten rock crept toward the main highway connecting the two sides of the island, closing in on infrastructure that hundreds of thousands of people depend on every single day. For a moment, an entire island held its breath, watching a sleeping giant remind everyone exactly who is really in charge. And then, just as suddenly as it began, it stopped. The lava cooled, the fountains died down, the world moved on. But Mauna Loa did not go back to sleep. Not really. Underneath that calm green surface, something has been quietly, patiently rebuilding ever since. Here's what the scientists are actually watching, and I want you to understand this clearly because it matters. Deep beneath Mauna Loa's summit sits a massive underground chamber, a reservoir carved into the rock where molten magma collects before it ever reaches the surface. After the 2022 eruption drained a portion of that reservoir, the volcano began doing exactly what it has done for millions of years. It started refilling. Fresh magma has been pushing up from deep within the earth, tight flowing back into that chamber, and as it does, the ground above it has been slowly, steadily swelling like a balloon being filled from underneath. This kind of ground swelling is called inflation, and it is one of the most important warning signs volcanologists look for anywhere in the world. When the surface of a volcano rises, it usually means pressure is building beneath it. And Mauna Loa's summit has been inflating on and off for years now, with monitoring stations recording measurable changes in the shape of the mountain itself. This is not speculation. This is not clickbait. This is data collected around the clock by instruments buried in the volcanic rock, watching every millimeter of movement. Alongside that swelling ground, there is the shaking. Every single month, seismometers scattered across Mauna Loa detect earthquakes, dozens of them, sometimes over 100 in just a 30-day stretch. Most of these earthquakes are far too small for a human being to feel. They register as faint tremors deep within the rock. Clustering in specific zones, scientists have learned to watch closely, areas beneath the summit crater and along what is known as the volcano's rift zones, essentially long cracks running down its flanks where magma has broken through the surface again and again throughout history. When earthquake activity clusters in these zones and increases month over month, it tells scientists that molten rock is on the move underground, forcing its way through fractures in the crust. Now, I want to be honest with you, because fear-mongering does nobody any favors and you deserve the real picture, not a manufactured panic. As of the most recent reports from the scientists who monitor this volcano every single day, the official alert level sits at normal, and the aviation warning code sits at green, the lowest levels on the scale. There's no eruption happening right now. There's no evidence that one is imminent in the coming days or weeks. In fact, the most recent monthly readings actually showed earthquake activity decreasing slightly compared to the month before. And when the ground, instead of continuing to swell, contracted just a touch. Scientists who study this mountain say this kind of push and pull, this rising and settling, has happened many times before during the years since the last eruption, as the volcano slowly, unevenly refills itself. It does not necessarily mean an explosion is around the corner. It might simply mean the mountain is breathing the way it always has. But here is why this story still matters, why you should still be paying attention, and why understanding this volcano is not just an academic exercise. Mauna Loa has a documented history that scientists take extremely seriously, a pattern spanning nearly 2 centuries of careful observation. And that pattern tells us something important. This volcano can go from quiet monitoring updates to fountains of lava racing toward populated areas in a matter of hours to days once conditions align. In 1881, lava flows from this exact volcano crept to the edge of what is now the city of Hilo, one of the largest population centers on the island, stopping just short of the town. In 1950, an eruption sent lava racing to the ocean in a matter of hours, some of the fastest moving lava ever recorded on the planet, covering more than 15 miles in under 3 hours. 15 miles. In 3 hours. That is faster than most people can drive through rush hour traffic. This is the defining characteristic that separates Mauna Loa from many other famous volcanoes around the world. Unlike a violently explosive volcano that might launch ash miles into the sky and bury everything nearby in an instant, Mauna Loa is what geologists call a shield volcano, built from countless layers of relatively fluid, fast-flowing lava that has oozed and raced across the landscape over hundreds of thousands of years, gradually building that massive, gently sloping shape that gives the volcano its name, because from a distance, it genuinely looks like a warrior's shield laid flat against the earth. That fluid lava is precisely what makes Mauna Loa so uniquely dangerous to the people who live near it. When it erupts, the lava does not creep, it runs. And there are hundreds of thousands of people living on an island where half the landmass is, quite literally, the single volcano. Entire communities, highways, hospitals, and critical infrastructure sit on its flanks, built across lava flows from past centuries. Every emergency planning document for the island takes Mauna Loa seriously. Not because scientists believe catastrophe is inevitable tomorrow, but because history has taught them that this mountain does not give decades of warning. Sometimes the gap between calm monitoring updates and glowing lava fountains lighting up the night sky is measured in mere hours. So when you hear reports of ongoing inflation, when you hear about earthquake swarms clustering beneath the summit month after month, this is why volcanologists do not shrug it off, even while keeping the alert level at normal. They know this mountain, they have watched it for generations, and they know that the current slow, patient refilling of that underground magma chamber is not a meaningless technical detail. It is the mountain reloading. Now let's step back for a moment, because Mauna Loa, as enormous as it is, might not even be the true, undisputed largest volcano on planet Earth, depending on how you define the word largest. Because there is something else out there, something almost nobody has heard of, hiding beneath the waves of the Pacific Ocean, and its scale makes even Mauna Loa look almost modest by comparison. It's called Tamu Massif, and it sits on the floor of the Pacific Ocean, roughly 1,000 miles east of Japan. When scientists finally mapped its true extent, they discovered something almost unbelievable. This single volcanic structure covers an area of roughly 120,000 square miles. To put that into perspective, that is larger than the entire state of New Mexico. It is nearly the size of the British Isles. One volcano, one single geological structure, roughly the size of an entire country, sitting quietly underwater, mostly forgotten by the world above the surface. Its roots reach an estimated 18 miles down into the crust of the Earth. 18 miles. That is deep enough to punch through layers of rock that most of us will never see or think about in our entire lives. For years, scientists debated whether Tamu Massif was actually a single volcano at all, or whether it was a cluster of several volcanoes that had grown together over millions of years, the way several small towns eventually merge into one sprawling city. But detailed seismic surveys eventually confirmed it. This really is one single, continuous volcanic structure, the largest ever confirmed anywhere on the planet, and one of the largest confirmed anywhere in our entire solar system, rivaling some of the massive volcanoes discovered on Mars. Unlike Mauna Loa, Tamu Massif is not actively erupting, and most scientists studying it consider it extinct, its volcanic activity having ceased somewhere around 145 million years ago, back when dinosaurs were still the dominant species walking the Earth. It built itself up not through a series of separate eruptions over time, the way most volcanoes do, but scientists now believe through a single, almost unimaginably massive and prolonged eruptive event, or a rapid sequence of events, that unleashed a colossal amount of magma across the ocean floor in a geological instant. We are talking about a structure built from lava flows that some researchers estimate could be individually more than 100 miles long. Flows so vast and so fluid that they are unlike almost anything else scientists have documented anywhere on the surface of the Earth. So depending on how you measure it, Whether by height, by total volume of erupted material, or by sheer surface footprint, you get different answers to the question of what truly deserves the title of Earth's largest volcano. Mauna Loa remains the largest active volcano, the one still capable of erupting, still monitored around the clock, still capable of threatening lives in the here and now. Tamu Massif holds the record for sheer physical size and footprint, an almost incomprehensibly massive structure that happens to be extinct and hidden from view beneath the waves. Both are humbling reminders of just how much raw power exists beneath our feet, power that dwarfs anything humanity has ever built or ever will build. But there is a third story here, one that connects directly back to the question of unusual activity, of volcanoes stirring after long periods of silence. And this one might be the most unsettling of all, because it does not involve a slowly refilling mountain everyone already knows to watch. It involves something that had gone almost completely quiet for thousands of years, something scientists only recently confirmed is beginning to wake back up. Off the coast of southern Japan lies a mostly submerged crater called Kikai Caldera. Most people have never heard of it, and there's a very simple reason why. Its most violent eruption happened roughly 7,300 years ago, long before recorded human history in that region, and it was almost certainly one of the most powerful volcanic eruptions of the last 12,000 years. An eruption so massive it collapsed the land above it, carving out the underwater basin that exists there today. For thousands of years since that catastrophic event, Kikai Caldera has sat mostly forgotten, a quiet crater beneath the waves, studied occasionally by researchers but not considered an active threat. That changed with a study that used advanced seismic imaging technology to essentially create an X-ray of what lies beneath that ocean floor. And what researchers found was extraordinary. Deep beneath Kikai Caldera, there is a massive magma reservoir, and it is the very same underground system that fueled that catastrophic eruption 7,300 years ago. That alone would be interesting, but not alarming, simply confirming the geological history of an ancient event. But then researchers went further, analyzing the chemistry of more recent volcanic material collected from the site, and they discovered something that changed the entire picture. The magma sitting in that reservoir right now is not simply the same leftover material from thousands of years ago, slowly cooling and settling into inactivity. It is new. Fresh magma has been injected into that system, rising up from deep within the Earth and slowly refilling a chamber that fueled one of the most explosive eruptions in recent geological history. Researchers have also confirmed that a lava dome inside that caldera has been steadily growing for roughly the past 900 years. A slow, patient bulge of hardened lava rising from the crater floor, evidence of the same underground system continuing to feed material toward the surface across millennia. This is a volcano that experienced a catastrophic super eruption thousands of years ago and has spent the time since quietly, steadily recharging itself. Now, before your imagination runs too far ahead, here is the sobering and honest truth that the scientists themselves emphasize, and it is important you hear this clearly. We, as a species, know remarkably little about what actually triggers a volcano like this to erupt again after a recharging period stretching across thousands of years. There is no reliable timeline scientists can offer. There is no countdown clock ticking somewhere in a laboratory. The researchers who made this discovery were careful and direct in stating that we are, in their words, ill-equipped to make specific predictions about when or whether this system might erupt again. This magma recharging process could continue slowly across additional centuries or millennia without any eruption occurring at all. Or it could be an early stage in a process that unfolds over a much shorter time frame than we might assume. Nobody can honestly claim to know for certain, and any content claiming otherwise is not telling you the truth. What makes this discovery genuinely important, beyond any single volcano, is what it reveals about how the largest and most dangerous volcanic systems on our planet actually behave. Kikai Caldera is not the only massive volcanic system scientists believe follows this pattern. This exact kind of large, shallow magma reservoir slowly recharging beneath the caldera has also been observed at other legendary volcanic systems, including Yellowstone in the United States and Toba in Indonesia, the site of a super eruption tens of thousands of years ago so massive that some scientists believe it dramatically impacted the global climate and possibly even human population numbers at the time. Understanding how Kikai Caldera is recharging gives researchers a working model, a comparison point for understanding these other sleeping giants scattered across the globe, hidden beneath American forests, beneath Indonesian jungles, beneath the floor of the Pacific Ocean. So here is where all of these threads come together, and here is why this story deserves your full attention rather than a passing scroll. We live on a planet that looks calm and solid from where we stand. Green hills, blue oceans, quiet mountains rising peacefully into the sky. But underneath that calm surface, the Earth is doing exactly what it has always done for billions of years. It is moving. It is building pressure. It is slowly, patiently refilling chambers of molten rock that once produced some of the most powerful natural events in the recorded history of our planet. Mauna Loa, the largest active volcano on Earth, sits right now in a state scientists describe as recharging, its underground reservoir slowly refilling since its last eruption, its ground swelling and settling in cycles, its earthquake counts rising and falling month to month in patterns that demand continuous, careful monitoring by teams of scientists working around the clock, every single day, without exception. Tamu Massif, the single largest volcanic structure ever confirmed anywhere on Earth, reminds us of the almost unimaginable scale of eruptive events our planet is capable of producing, even if that particular giant has been silent for 145 million years. And Kikai Caldera, a nearly forgotten crater beneath the waves off Japan, has just revealed to scientists that it is quietly rebuilding the very system that once produced one of the most violent eruptions in the last 12,000 years, a discovery that forces researchers to reconsider what we thought we understood about how long a volcano can sleep before showing genuine signs of returning to life. None of this means the sky is falling. None of this means you should be losing sleep tonight over an eruption that might be centuries away or might never come again in any of our lifetimes. But it should absolutely change the way you think about the ground beneath your feet, the mountains you might have driven past without a second thought, the ocean floor stretching out beneath ships and cargo routes carrying goods across the Pacific every single day. Our planet is not a finished, static object. It is an active, breathing system, constantly rebuilding itself in places most of us will never see, guided by forces operating on timescales so vast that a single human lifetime barely registers as a blink. Scientists spend their entire careers watching these systems precisely because the stakes are so enormous. A modern eruption from a volcano like Mauna Loa could threaten hundreds of thousands of lives and cause billions of dollars in damage to critical infrastructure in a matter of hours. A genuine super eruption on the scale of what happened at Kikai Caldera 7,300 years ago, should it ever happen again in the modern era, could affect global climate patterns and agricultural systems for years afterward, an event capable of reshaping life for millions of people across an entire hemisphere. These are not hypothetical movie plots. These are documented events already written into the geological record of our planet, events that have happened before and, given enough time, will almost certainly happen again somewhere on Earth. This is exactly why the unglamorous, quiet work of volcano monitoring matters so much, even when the headlines make it sound more dramatic than the actual data supports. Every single month, teams of scientists collect thousands of individual measurements, seismic readings, ground deformation data from satellites and precision instruments, gas emissions sampled directly from volcanic vents, subtle temperature changes tracked across years. Most months, that data confirms what everyone hopes to hear. No significant change. Alert level remains normal. Nothing indicating an imminent eruption. But that consistent patient monitoring is precisely what allows scientists to catch the earliest possible warning signs when a system genuinely does begin shifting toward eruption, giving communities the priceless gift of time to prepare, to evacuate if necessary, to protect lives that would otherwise be caught completely by surprise. So the next time you see a headline claiming Earth's largest volcano is showing unusual signs, I want you to remember what you learned today. The real story is rarely as simple as a single dramatic headline makes it sound, and it is almost always more genuinely fascinating than the exaggerated version once you understand what is actually happening beneath the surface. Mauna Loa is not erupting today, but it is slowly, steadily recharging, exactly as it has done many times across nearly 2 centuries of recorded history, a natural process being tracked in extraordinary detail by scientists who take absolutely nothing for granted when it comes to a volcano capable of producing lava flows fast enough to outrun a car. Tamu Massif reminds us just how staggeringly large a single volcanic structure can grow across geological time. And Kikai Caldera has just shown the entire scientific community that even a volcano silent for over 7,000 years can still be quietly rebuilding itself in the darkness beneath the waves. We like to think of the ground beneath us as permanent, unchanging, something solid we can always rely on. But the truth is far stranger and far more humbling. Beneath every mountain, every ocean floor, every quiet green hillside, the Earth is still working, still building, still moving material that has been in motion for billions of years and will keep moving long after every single one of us is gone. Somewhere beneath Hawaii, right now, magma is rising back into a chamber that could one day send lava racing toward a coastline again. Somewhere beneath the Pacific, an ancient giant lies silent, its record-breaking scale still being studied by scientists who have only fully understood its true size in recent years. And somewhere off the coast of Japan, a caldera that once produced one of the most powerful eruptions in thousands of years is quietly, patiently filling back up, waiting, on a timescale none of us can fully predict. Think about what it actually takes to watch a volcano like Mauna Loa properly. It is not one scientist standing on a rim with a notebook, glancing down into a crater every few weeks. It is an entire network of instruments buried across the mountain, seismometers listening for the faintest tremor, GPS stations precise enough to detect ground movement measured in mere millimeters, gas sensors sniffing the air for the earliest chemical signatures of rising magma, satellite radar sweeping over the summit again and again, comparing the shape of the mountain today against the shape it had yesterday, last week, last month. All of that data pours in constantly, day and night, and it gets compiled into monthly reports that most people will never read. Quiet bulletins that rarely make headlines because most months, nothing dramatic happens. But those quiet, unremarkable months are exactly what makes the system work. They build the baseline. They teach scientists what normal actually looks like for this specific mountain, so that when something genuinely does start to shift, they recognize it immediately instead of dismissing it as noise. And that baseline has been built the hard way, through decades of hard-won experience. Go back to 1984, the last time Mauna Loa erupted before its long silence broke in 2022. That eruption sent lava flowing to within 4 miles of Hilo, one of the largest towns on the island, in a matter of days. Go back further, to 1859, when a Mauna Loa eruption produced a lava flow so long it traveled more than 30 miles from the summit all the way to the ocean, one of the longest lava flows ever recorded anywhere on the planet. These are not obscure footnotes buried in a geology textbook. These are the exact reasons modern emergency planners on the island treat this mountain with the seriousness it demands, building evacuation routes, mapping historical flow paths, running drills, and briefing communities on what an eruption could mean for their specific neighborhood, long before any crisis actually begins. It is also worth understanding just how strange and singular Hawaii itself is, geologically speaking, because it helps explain why a volcano this size even exists here in the middle of an open ocean, thousands of miles from the nearest continental landmass. Most of the world's volcanoes form along the edges of massive tectonic plates, where one slab of the Earth's crust is either colliding with another or pulling apart from it. Hawaii sits in the middle of a single plate, nowhere near an edge. Instead, it exists because of what scientists call a hotspot, an unusually hot plume of material rising up from deep within the Earth's mantle, burning its way through the crust above it like a blowtorch held beneath a sheet of ice. As the Pacific Plate has slowly drifted over that stationary hotspot across millions of years, it has left behind an entire chain of volcanic islands in its wake, each one born directly above the plume, then slowly carried away as the plate continues moving, eventually going extinct as it drifts beyond the hotspot's reach. Mauna Loa sits almost directly above that plume right now, which is precisely why it remains so relentlessly active, while its older island neighbors to the northwest have long since gone quiet. That single geological fact tells you something important about the future. This hotspot is not going anywhere. It has been feeding volcanoes in this region for tens of millions of years, and it will keep doing exactly that long after Mauna Loa itself eventually drifts away from it and falls silent, the way its ancestors did before it. Even farther out to sea, scientists are already tracking the birth of the next volcano in this same chain, a young underwater mountain slowly building itself layer by layer on the ocean floor, decades or centuries away from ever breaking the surface. The hotspot does not create a single mountain and stop. It creates an assembly line, one that has been running since long before human beings existed to watch it. Now bring that back to Kikai Caldera for a moment, because the discovery there raises a question that genuinely unsettles even seasoned researchers. If a volcanic system can experience a catastrophic, history-altering eruption, then sit in apparent silence for over 7,000 years, while secretly recharging the entire time, how many other calderas scattered across our planet might be doing exactly the same thing right now, hidden from view? Earth is covered in ancient calderas, quiet basins, and depressions, left behind by eruptions so far back in prehistory that most of them carry no written record at all, only the physical scars pressed into the landscape itself. Some of those calderas are almost certainly extinct for good, their underground plumbing sealed off permanently, never to stir again. But others may be doing precisely what Kikai is doing beneath the waves off Japan right now, slowly and patiently rebuilding, decade after decade, century after century, waiting on a timeline no living scientist can fully predict. That uncertainty is not a reason for panic. It is a reason for humility, and it is a reason for continued investment in exactly the kind of quiet, unglamorous monitoring work that rarely trends online, but genuinely saves lives when it matters most. Every dollar spent maintaining a seismometer network on the flank of Mauna Loa, every research vessel sent out to map the seafloor around a caldera like Kikai, every satellite pass measuring the subtle swelling of ground half a world away, is part of the same enormous, ongoing effort, trying to understand a planet that is still very much alive beneath our feet, still moving on timescales that dwarf a single human life, still capable of reminding us, in a matter of hours, exactly how small and fragile our modern world truly is against the raw power stored inside the Earth itself. That is the real story. Not manufactured panic, not a countdown to disaster next week, but something far more powerful in its own way. A genuine, humbling reminder that we are living on top of a planet that is very much alive, still shaping itself. It's still capable of producing forces beyond almost anything human beings have ever built or ever will. And the scientists who study these systems are not chasing headlines. They are quietly doing the work of watching over all of us, so that when the ground truly does have something urgent to tell us, we will actually be listening.